Welcome, everyone, and thank you for joining this DZone Trend Talks discussion on cognitive databases, intelligent data. I'm your moderator, Jesse, and I'll be guiding today's conversation with our panel of experts. Today's discussion is grounded in DZone's 2026 Database and Data Engineering Research and the related trend report. The research shows a data layer that is broadening rather than consolidating. Relational systems still at the top. Document and multi-model platforms are almost as prominent, and organizations are also working with columnar analytics, operational NoSQL, distributed SQL, time series vector, and graph databases. The focus today is going to be very practical. We're going to look at how organizations can manage hybrid database strategies, data movement, performance. Of course, we'll get into AI-assisted operations, governance, retrieval, and everything, all the way down to AI-ready infrastructure. But first, I want to introduce our panelists. So first up, we have Matthew Groves, DevRel Engineer at Couchbase. Welcome. We have Jubin Soni, Senior Software Engineer at Yahoo. And Anusha Covey, Business Intelligence Engineer at Amazon. Y'all, welcome. So glad you're here. So the first thing I want to get into, obviously, starting with the research that we have in the trend report. But the research is pointing to this broadening of the data layer rather than like clean replacement cycles, switching things out. Relational systems still at the top, as we said, and then these other systems are still underneath it. We have everything all the way down, graph and vector databases, right? Not as prominent as relational, of course. But the practical question we want to dig into is which database to choose used to be the question, but now you have to keep up with a mix of databases, different pipelines and different data access layers. So Netflix coined a term many years ago, the polyglot database setup, right? Which was huge, many moons ago, but it's something that we're still living in today. And the organizations that live in that are split between all of these types of databases, right? Whether they're operational, analytical, warehouses, lakehouses. We have batch, ETL and ELT, real-time replications, change data control. I mean, everything. This creates a challenge, as you know, and I want to talk a little bit through that. So when you look at the current stack, I just said a lot of word soup, but when you look at that in enterprise organizations, where do you see specialization helping teams, and where does it start to create friction? And Matthew, let's start with you, buddy.
Yeah, so I think it's a great setup, Jesse. Thank you for that. I think vector search is a really good example of specialization that you mentioned. When an app needs semantic search or RAG or some sort of use case like that, the right index and query model really matters. And so having operational data and vector search closer together can avoid some of that plumbing. But to your point about the polyglot database, I think that was definitely a trend back in 2008 or whatever, when Netflix was first starting to take off. But I think that every one more database adds issues, adds sync issues, freshness issues, security, monitoring, ownership problems, and maybe that architecture diagram looks impressive on a Netflix slide, right? But there's so many parts there that can break, increase costs and risks. And I think of polyglot databases more of a data sprawl. And that's one thing that Couchbase we're trying to avoid. It's going to be a theme of mine today, probably, is yet another copy of the data. Every time an app needs to add search or cache or mobile or vector or operational data, you don't just tack on another database to that.
Okay. Jubin, anything for this? Like, where do you see things going?
Yeah, so when you start with like something like a Postgres database, then add Redis on top of it, and then add Elasticsearch and a vector database, your app grows, and then your team starts sensing that the data is now at 4 places. So touching at the same points that Matthew mentioned. So the biggest headache is the syncing, keeping all the databases synced. And the database choices are fine, but the coordination between them becomes a real problem because you have many different places to manage. And so the key thing over here is, before adding any specialized database, think can the existing database achieve the same thing? So for example, before adding a specialized vector database for solving a RAG problem, see if a PG vector in a Postgres database that you already have, where you where you can have the embeddings over there solve the problem. And in most cases, for most teams, it does solve the problem. So you just create like an embedding document within your Postgres database that sits as an additional column with your existing data that most of the time solves the problem. Um, so so yeah, so the data engineering now determines like your DB choices matter even more, especially as we are entering the AI era, and we have more applications for the system design and the AI.
That's a good point, and it's a tough choice. I mean, that would be the question that I had on the back of Matthew's is, and you just kind of answered a little bit of it. How do you decide when to add another database or not? Right. Step one, see if you can already get value out of something that you already have without incurring that tech debt. I love it. In this idea of it being sprawl rather than just impressive architecture, I like. And Anusha, for like engineering leaders out there, where do these boundaries sit? Like, how do we see between the operational, analytical systems, cloud, legacy? There's all these boundaries. So where do you think the hardest decisions are when making, your choices between those?
Yeah, thanks for this question. So there was a pattern which when I was working, I was looking into. So, teams get excited building these AI layers or AI generated reports or these LLM based assistants, right? And at that time, demo works and leadership gets impressed after looking at it and they ship it. But after shipping, that's where the complaints start. AI, gives the wrong revenue number and the dashboards are mostly right. But at the time of investigation, you understood that it's not the model problem. It's the, which metric definition does the AI take? So that's where the issue is coming. So the one thing which the leaders or any leaders, data engineering leaders or software engineering leaders should keep in mind is they need to be adding meaning layer before they scale the AI layer, not as a data engineering project, but take it as a governance project and scale it. So if you want to enhance the trust or like build the trust, you need to build all these layers or the governance or metric contract layers and then ship the AI products.
Interesting. All right. So I want to talk, Matthew led us this direction, so I want to lean into it on modernization, right? There's a lot of different ways to view modernization. I was using and writing database drivers back in the 90s, right? So back then, relational was king. It still sounds like it's king, right? Adding a bunch of stuff around it. And I think Matthew will get that in a minute. But these relational manual operations, they're still a huge part of organizations. They haven't gone anywhere, right? We call them dinosaurs, but they're not extinct. Now you've added in cloud managed database, workload specific platforms. People are trying to do consolidation, but are getting sprawl instead. Now you've got these AI assistants that we just talked about with Anusha and Jubin. Like, this is a very complicated, mixed environment. And legacy systems don't typically disappear. They get surrounded by newer services, pipelines, indexing layers, right? Requirements for governance. So and Matthew, for you first, what does database modernization really look like when teams can't really retire or replace, or can they, right? These older systems before they adopt these capabilities? It sounds really hard.
Yeah, it is really hard. And this is exactly how I described it. It's that legacy relational core with maybe cloud services around it. And then we're adding now the newer AI and search features on top of that. And most companies at this point are not necessarily replacing everything, or they maybe want to consolidate, but they're kind of making new and old coexist right now. And at Couchbase, we often show up in those layered modernizations because you can put our flexible model and distributed operational layer next to those existing systems instead of ripping everything out. But we do have some customers who are taking a more aggressive approach to this. A customer like Marriott, for instance, who is saying we want to standardize on one data platform, maybe just a couple data platforms to kind of reduce that. That's a very difficult problem to tackle for sure. But yeah, for the most part, companies right now are just kind of making those new and old coexist. And one of the things that echoing Jubin from earlier is that when you want to add a specialized system to your application, you only do that if it removes more complexity than it creates, right? Because there is a tax there when you add a new system, is moving data into that or copying data into that, and all the governance and licensing, all the stuff that goes along with that. So only add if it reduces complexity.
Okay. All right. Now, what does modernization look to you, Jubin? What does that look like to you?
Yeah. So it's modernization is in the data system is introducing a new data store alongside the old one. So, for example, your team wants to modernize, say, from a legacy database system to a new one, and but then you can't just modernize in like one day or like in 1 week. It's hard because so far your team has relied on it. Your systems, your consumers have all relied on the old data, and of course, you're modernizing in the first place because there are problems with the existing one. You can't just decide to simply modernize. The new system provides a lot of benefits, but when you are modernizing, the key takeaway is to make sure that the old one and the new one, you push the data to both the places, and make sure that the system is working. You test it out fully, and then you have to also make sure the upstream and the downstream services that are consuming remain the same. So the key over here is having the data contracts and the event contracts. So instead of pushing like a like the same, like make sure you push the same schema and the guarantees of the freshness of the data to the downstream systems, similar as the old one. So yeah, that's what modernization to me would be like, making sure that the downstream systems are as less affected as possible.
Okay. Anusha, anything you want to add there? I've
Yeah.
got another question. If not, I'll go and then I'll do that one and I'll give you another one.
Sure. Thanks for asking this. I would like to give the example of modernization here. I mean, moving from the legacy systems to cloud is also a modernization, right? So, and when we are moving from legacy to cloud, some of the employees like who are involved in those migrations might not be having the knowledge of like how should they migrate, what steps they need to actually take to migrate, right? So we need to the employers need to train the employees first. So that would be a time they need to allocate, and that would be a cost overhead. And after taking multiple steps of migration to legacy to cloud, right? We need to also validate the data. Are the reports looking good with the data which is there in the cloud? So all these steps are a lot of overhead for the company, but they also need to trade off with what are the advantages they would be getting in with this. So for me, modernization is like adding a overhead, but it also like comes with advantages. If the advantages are more than whatever the risks or things, risks or costs which the employees are taking, then I would go with modernizing the thing. Also, after modernizing, if that helps with this AI era, I would definitely go with it.
So you listed a few things out. What would you say is the first step? Organizations that want to do this without being so disruptive, what's the first step they should take?
First, for the example which I mentioned, which database or which cloud system they would like to migrate, they need to research first about those. For their legacy systems or the data architecture, what they have, which cloud provider would that fit? So researching that would help. That would be the first step, first essential step that the company needs to do or the employer needs to do.
Good. And Jibin, same question. Like, if you're going to go through modernization, first steps, like what do you do first?
Yeah, first step is identifying the use case. Like what is the new system solving for your customers, and what are the benefits it's providing. And then it's also identifying. It's a lot of like the spike work that we call in engineering, which is identifying how we would read and write the right paths, and then making sure that tracing the downstream consumers are less affected as possible, and how we can achieve this without breaking anything for the consumers. So, yeah.
Okay. And Matthew, what would you want to add in there?
Sure. I agree with a lot with Jubin there about the use case identification and the spikes and a proof of concept. I think we also need to think about the integration debt that exists in the system, if there is any. Not every organization is like this, but some places have like a set of mystery jobs, moving data around, or one-off ETLs. There's an unclear source of truth. You're laughing, Jesse. I'm sure you've experienced these before.
But yes.
Shadow ETLs or shadow data layers. And so I think to Jubin's point about upstream and downstream, being able to standardize how data changes move between systems, pick a lane basically. Is it like a CDC? Is it event-based, contracts, API, something like that? You did mention schemas can be a sticky point though. And that's why you need flexibility in your data stores as well when you're moving data around.
Awesome. I laugh because AI is making that problem of these little pet projects that move little bits of data around. It's going to make it way worse because people can do that in just an instant, right? Instead of, doing a real change. So I laugh because we're going to come back to that. You get surprised. You're in the middle of a migration. Something doesn't work. Well, what happened? Well, I wrote this thing last year. Yeah, it's a terrible, terrible issue. But I want to move on to performance, right? Performance is kind of a big deal. Optimizations always shows up in our trend report. And things have changed a little bit, right? Used to be you could optimize your SQL queries, not doing table scans. You run some indexing and you're good to go. Now, like we're distributed across partitioning. We got to think about sharding and clustering, managing workloads, automated query optimization, which happens, automatically. Storage, tiering, capacity planning, elastic scaling, you name it, is all in there. So this manual query tuning and indexing that I'm used to still matters, but it's not the whole story anymore, right? In these distributed architectures, latency can come from a whole bunch of different places. Data movement, replication, transformation jobs, you name it, not just from the database engine. So how should engineering teams change the way they look at performance? Like, how do they change their playbook when the bottlenecks can sit almost anywhere? It's not just a query, it's a whole thing. How do we debug the pipeline, so to speak? Anusha, any advice practically out there for people looking to do this?
Yeah. So, couple of examples I would like to bring out here, because it's not just a query. The performance issues doesn't come from the query itself. It's like architecture as well. You need to consider, right? So, first example is, let's say one morning you get an alarm since a dashboard query was timed out. So then you go and check the query plan and it looks clean, and you execute that in the development environment, and it runs within seconds. So now you think of like why it's not working in production. So you dig deeper and go and find it. So you have understood that there is an upstream replication job, which is actually syncing from the source system, which is during the peak hours. So the query isn't slow, but it's actually waiting. That's why you were hit with a alarm. So the second example, what I would like to bring here is, let's say there is a monthly aggregation pipeline, which runs overnight, but this hasn't finished. And the next day, business users have come and started pulling the reports. Now, the query is technically valid, but the table, which is like behind the pipelines, is half loaded and the answer is wrong. So here the SQL query is not wrong. It's like the data isn't fully loaded. So the bottleneck here, what I would say, is not the query, but it's the pipeline or the infrastructure here. And here is where it would actually get even worse when AI is added to it. So an AI analyst knows like when to wait, right? But I mean, until this aggregation finishes, but the model doesn't. So it generates a valid SQL and gets a result, right? And publishes the wrong monthly data confidently. So it's not a model problem, but it's a scheduling, lineage, or a observability problem. So the system needs to know like not just what data exists, but when it's ready. So I think we need to build some type of architectural contracts behind it, so that or like a skills document out for each of the pipelines or each of the infrastructures, in order to tell the system, like be ready for the system, like when these would be ready and when it should be like starting it. So that's where I would be going with it.
Awesome. Matthew, what do you want to add there?
So performance at scale it's like a key pillar of what we do at Couchbase. We spend a lot of time on that, and we've solved a lot of those problems with distributed caching, sharding, which is why like LinkedIn and PepsiCo uses us for their very large use cases. So when we ever see support tickets or users come to us and they say, hey, this query is slow, it's often not an issue with necessarily the query, but like Anusha was saying, it's something like replication lag, or maybe some bad workload placement. Some app side stitching is a common one, where you're actually pulling in queries from multiple places and stitching the results together in the client layer. So sometimes the fastest way to run a query is don't send it across 3 systems in the first place, right? So if you have a system that can handle key value search and vector together with the operational data, you can cut down on something like app side stitching, for instance.
It's funny, the guy went to the doctor, says, it hurts when I move my hand this way. Says, don't do that. I love that. Yeah. Stop doing those things. Jubin, anything you want to add?
Yeah, I want to add a quote over here that echoes a lot of points of Anusha and Matthew, is that performance problems are not about speed. They are about contention and placement and the scale boundaries. So it's about the and then another point I want to make is the checking the tail latencies first. So if your P50s are looking fine, but your P99, P90, that's where the problem is. So a lot of APM tools, logging tools like Splunk, Datadog that most teams already use might be able to help with that.
Yeah, I was going to say, where are you getting all your metrics from, right? Yeah. Track that down. I love it. All right, so we got a few minutes left. We're going to jump into AI now. We have to. AI is in everything, right? But as we jump into that, right, this AI assisted query optimization, right? It's being piloted. People are using it in production. Mostly it's bounded, right? So that's recommending, or we're putting these guardrails around tuning, kind of limiting the continuous optimization. Full self-management, usually not a very common thing that we see. AI can reduce a lot of manual effort, but I think it also raises this need for more visibility, right? Explainability, rollback, operational trust. Like, where in your mind do these AI assisted database capabilities deliver clear value today? Anusha, why don't you go first?
Sure. Thanks for the question. That's an important discussion we would like to have, actually. So recently, when I built this prototype, which we can call it as a simple AI assistant, right? Which generates a SQL query when user prompts it, right? And you ask a question. Let's say, what's the yearly revenue, 2025 or 2026 revenue? So it gives a number, right? So it has given a number, and you have understood that it is far away from whatever the number which you have seen in the reports, actually, right? And so in my database, revenue would mean maybe net revenue after refunds, right? Or gross order value, or a paid revenue. But the model, the AI assistant which I built didn't understand that. So this is the real danger, right? with automation. So it doesn't fail. It doesn't fail loudly, but it succeeds quietly with the wrong answer. So what I have actually, to overcome that problem, what I have done is, before that that SQL reached out the database, I have like written some kind of definitions, like metric definitions, in the form of a JSON format, or like in a YAML file, saying that, like, if for example, one metric, what is the name, what is the columns it should use, what is the filters it should use. So all this, as a packet, I have given to the AI assistant, so that whenever it generates the SQL, it would be taking that as an input and then generating. So this is where explainability also comes, like trust from the user also comes. It can like output like which filter it has used, which time bound date range checks it has used. If that is actually outputted in the screen, user can actually trust, like the AI assistant is now explaining the user that it has actually used all these and generated the answer, right? And also for the rollback thing which you have asked, when a metric definition is actually changing, now the report, or WBR report or the XBR report now changes. Then you need to understand where did the metric definition actually change. So here the version controlling should also be there, not only for the code but also for the metric definitions you change in those files. So automation is an aggressive thing, but rollback also should be added to make it strong.
Got it. Very cool. All right, Matthew, what do you think? How do these, how do we deal with all this AI stuff, and what is it really delivering in terms of value?
Yeah, I think we're talking about AI. I think of a coding assistant like a Capella IQ and Couchbase, or like an MCP server that allows you to interact with a tool like Couchbase or other tools. And so I think of those as, I think the assistants as an advisor, right? Definitely more of a co-pilot, not an autopilot, right? I am very, very comfortable with AI recommending an index because I'm personally not great at creating great indexes. But I'm much more cautious about allowing AI to create that index in production on its own, right? And as like Anusha was saying, I want to have explainability, I want approval, I want some sort of history, maybe source control, rollback, things like that. And if MCP is involved, I want that tool to be, the tool surface there to be scoped very tightly, right? I don't want the agent getting access that it shouldn't have, or even access at all without a human involved in some way. So I think that is, we need to think of AI as, at least today. Maybe it'll get better in the long run, but right now I think that's what we need to treat it like.
Like an advisor. And like Jubin, anything you want to add there? Like when we're using it as an advisor, how do we validate the recommendations before we act on it too, right? What do you think?
Yeah, I agree with a lot of points Matthew and Anusha spoke. So using AI as a co-pilot rather than on autopilot. So when we are running an AI into production today, and there are a lot of operations like the engineering operation or the API operation. Would you trust an AI today with delete operations? So if an AI is making, say, deleting orders, and what if it gets to the wrong shard and deletes wrong orders? Would you trust them with like bulk delete operations today? So it's those are very risky operations, and if you let it run on autopilot, then that can cause a lot of real customer impact and an immediate incident for a lot of companies. So making sure that a human in the loop is also very important in such cases, that when there is a high blast radius for such operations, having a human approver review them, and also having audit log for every input and output what an AI agent makes. So audit logging becomes even more important today. So just like audit logging we have for humans, but having even audit logging with an agent ID, with the input, with the output, what action it took, when it took, timestamps. So and then having a tested rollback plan when your if you have to have an AI agent doing like the database operations. So and then human judgment stays essential more than ever.
That's awesome. Yeah, I love that. The audit log thing is a great idea. Well, we're at our time. So, but I have one more question that I want y'all to get to. I want to come back to our central theme of research, right? Database strategy depends on like enough cohesion across all these databases and pipelines and access layers to support performance control. And we also have to have AI readiness at the same time. As Matthew said, you want to try to avoid the sprawl, but you still want to use specialization when it's necessary. As we talk about all this diversification and modernization, performance and AI, like what's one thing about the data stack that engineering leaders should revisit this year? So you're going to sit down with an engineering leader and you're going to have an hour with them, right? What is it that you're going to pass on to them on something that's coming in the next year? They need to be looking out for that they might be assuming that's wrong. Like what's your advice? And Anusha, we'll start with you.
Sure. So one advice, I mean, from my mistakes, what I have learned is building out the governance layers even before you build an AI product out of it. Because that is the main input you would be giving for the AI to scale or like to improve the trust with the tool, which the people will be using like in a long term. That is one advice I would like to give.
Okay, awesome. Jubin, what do you think? And then Matthew, we'll wrap up with you.
Yeah, so having ownership of is more important. So when I would like to give an example of a RAG chatbot. So it works great 6 months in, and but if you have your team built it, but then when the source documents are updated, the vector index also needs to be updated. So treating AI as or all your AI products or your features as a complete consumable product and having clear ownership. So that's what I would like to say to the engineering leaders. That whenever you update your documents, having a clear lineage and the downstream pipe system or the team ownership connected to that system, that the updates are constantly being made as the systems and the relevant document and the caches and everything is being updated. And then also having an like access control or the and like inheriting from the source, so that whenever any deletions are also made, they are also being invalidated into the AI.
Okay, awesome. All right, Matthew, you've got an hour with engineering leader. What are you going to lay on them?
I think I'm going to do it very similar to what Jubin has said. I'm going to map those critical data paths that are feeding AI. The source, the movement, the freshness, all those sorts of things. How it moves, how it changes, who owns it, what permissions are there. Putting AI on top of those paths I don't understand is risky because the AI is only going to be as trustworthy as that chain underneath it. And so again, from a Couchbase perspective, this is where reducing that sprawl really matters. If every AI use case creates another copy, another pipeline, another mystery job, governance gets harder. The goal should be fewer copies and clearer access patterns, especially around the operational data. So I think ultimately, I'm going to tell this later, AI readiness is not just, hey, add vectors. It's whether that data layer can be trusted when the answer actually matters.
All right. We might have time for this last one. And I want to ask it. So what should teams stop doing? We just gave them some advice from leaders on what they should do. So what should they stop doing as they're moving towards adopting more of this AI-ready data infrastructure? There's danger there. So I want to hear what you think. Jubin, why don't you tell us what you think first?
Yeah. So one thing teams should stop doing is stop debugging the symptoms in the code when the root cause is often at the architecture level and the load patterns and the data flow. So stop chasing the slow queries before checking the workload patterns and the contention, and stop adding new systems before understanding the real bottlenecks.
Okay. Anusha, one thing.
Okay. So I don't want teams to use AI for the sake of using it. For all the use cases, you don't need AI to, use it. You can simply, do a project without AI maybe in 2 days, right? But if you use AI, it might take 5 days. For example, Excel modification projects, something like Excel, reports, if you are making AI, I don't think it would be doing a great job in doing those formatting things or writing formulas. Yes, I agree, but writing formulas in those cells which you want. So for all these, this is just an example, but there are a lot of examples where AI might not be useful, where a human actually can do the job quickly, right? So don't use AI for the sake of using it. If there is a real use case of AI where you will be seeing productivity improvements, there use it.
Awesome. Good advice. All right, Matthew, wrap us up.
I think customers are with Couchbase because they've had production issues in the past. So my advice would be stop optimizing for the fastest demo and start optimizing for production. Who owns that data? Is it fresh? Are permissions preserved? Can we roll back a bad change? If the answer is no, that prototype is not ready for production.
Gotcha. Good stuff. Thank you all for that. Thank you to the panelists, each of you, for joining us today. That's great. Thank you for sharing your perspective. Thank you for sharing your wisdom and your expertise. And thank you to everyone out there who joined us for this DZone Trend Talks discussion. We encourage you to go out and read the full Cognitive Databases Intelligent Data Trend Report. For all the context behind this talk, you can get that at dzone.com and join us and get access to all the other content that's just like this. All the research findings, tons of practical guidance that can help you on your journey. We'll see you next time.